Have you ever looked up at the night sky and wondered how it all began? How the universe went from just nothing, complete darkness, to this incredible fireworks display of stars and galaxies? Well, today we're going way, way back in time to meet the cosmic architects that literally flipped the switch on the universe, the very first stars. And let me tell you, these were not your average run-of-the-mill suns. They were absolute giants, and they built the universe we know today.
It's a huge question, right? After the Big Bang, the universe was just this vast, dark, and incredibly silent place. So how did we get from that to the vibrant cosmos we see today? The answer, it turns out, is an absolutely epic story of creation and destruction, one that begins in an era of pure, total darkness.
I mean, try to imagine it. For hundreds of millions of years, an era astronomers call the cosmic dark ages, there was nothing. No stars, no galaxies, not a single pinprick of light. Just a silent, endless sea of gas, left over from the very beginning of time.
Okay, so to really get how the first stars came to be, we've got to look at what the universe had to work with. What were the raw materials? It was a surprisingly simple place back then, but it held all the seeds of everything that was to come.
So the recipe for the early universe was super basic, pretty much just hydrogen and helium. But what's really important is what was missing. It was missing everything else, what astronomers just lump together and call metals. You know, carbon, oxygen, iron, the works. And this one missing ingredient is the entire reason the first stars were so incredibly different from the ones we see today.
So, how do you get from a simple cloud of gas to a star? Well, gravity starts to do its thing, pulling that gas into denser and denser clumps. But remember, there are no heavy elements, and that's the key. Without those elements to help cool things down, something truly spectacular happened. The universe didn't just make stars, it made monsters.
You see, when stars form today, those metals act like super efficient refrigerators, cooling the gas clouds down. This lets the cloud break apart into lots of small pieces, which then form lots of smaller stars, like our sun. But back then, the only coolant around was molecular hydrogen, which is, honestly, it's terrible at the job. So the gas just couldn't cool down and fragment. It just kept collapsing into one single, massive core.
And these primordial giants, they have a name. Astronomers call them population 3 stars. Yeah, the naming is a little backward. They came first, then came population 2, and now we live in the era of population 1 stars, which includes our sun. But Pop 3 stars were the originals, forged from that pristine, untouched gas of the early universe.
Because of the way they formed, these stars were, well, they were extreme in every sense of the word. Their lives were unbelievably brief, incredibly violent, and absolutely essential for the future of the cosmos. They burned with an intensity that is just hard to wrap your head around.
First off, their sheer size. We're talking about stars that were hundreds, maybe even up to 1,000 times more massive than our sun. They were true behemoths, the undisputed heavyweights of the cosmic dawn.
And all that mass made them unbelievably hot. Their surfaces were blazing at over 100,000 Kelvin, just pumping out these immense floods of high-energy ultraviolet light that started to tear through the dark, foggy universe around them.
But here's the catch. Being that big and that hot comes at a steep price. They burned through their nuclear fuel at an absolutely furious rate. They only lived for a couple of million years. To put that in perspective, our sun is going to live for 10 billion years. The entire existence of a population 3 star was just a cosmic blink of an eye.
And their deaths? Just as spectacular as their lives. Many of these giants didn't just go supernova. They were completely obliterated in a special, terrifyingly powerful kind of explosion called a pair instability supernova. A blast so big, it tore the star entirely to pieces, leaving nothing, and I mean nothing, behind. No black hole, no neutron star, just stardust.
But their deaths weren't really an ending. In fact, they were the most important beginning in the history of the cosmos. These stars were the architects of the modern universe, and their explosive deaths were the catalyst for, well, everything that came next. Because inside their fiery cores, they were cosmic factories, forging the very first heavy elements the universe had ever seen. And when they exploded, they scattered those brand new atoms, carbon, oxygen, iron, all across space. They enriched the primordial gas, giving the next generation of stars a whole new set of ingredients to work with. So they left behind 2 incredible legacies.
First, that intense UV light I mentioned, it burned through the fog of neutral hydrogen gas, ending the cosmic dark ages for good and making the universe transparent. And second, they performed the very first act of chemical enrichment, creating the elements needed for rocky planets and eventually for you and me.
Now, this isn't just some cool story from the past. For decades, these stars were purely theoretical, just an idea. But today, right now, with incredible new technology, scientists are on the hunt for the echoes of these cosmic pioneers.
And we have come a long way since the 80s, when this was just a theory. The big game changer is the James Webb Space Telescope. This incredible observatory was basically designed to be a time machine, to look back to the cosmic dawn and find the light from these very first stars.
And the results we're getting are just breathtaking. Now, JWST isn't seeing the stars themselves, they're long gone, but it's seeing their ghosts. It's seeing their chemical fingerprints. By analyzing the light from the most distant galaxies imaginable, astronomers are finding the exact chemical signatures of the elements forged in the hearts of these first monster stars.
And this is the part that really brings it all home. The carbon in your DNA, the calcium in your bones, the iron in your blood, every single bit of it, was created for the very first time inside one of these population 3 stars. We are, quite literally, made of their ashes.
And that leaves us with one last, really fascinating thought to chew on. These cosmic architects, they didn't just seed our little corner of the universe, they seeded the entire cosmos. Their legacy is everywhere. And that just makes you wonder, if their work led to life here, what else might be happening out there?